Right. Hello and welcome, everyone. My name is Jonathan LaCour, and welcome to today's presentation on serverless location tracking using AWS Lambda, S3, and Athena. I'm excited to share some fun technology with you today. A little bit about me first. My name is Jonathan LaCour. I am the Chief Technology Officer for Mission, a leading AWS consulting and managed services provider. I'm a technologist, programmer, cloud strategist, and lover of bespoke suits. I'm not unfortunately wearing one today. I wish I was, but didn't have time. And as we go through today's presentation, I would encourage you to ask questions. I will attempt to monitor the chat for questions as we go. I have one of my coworkers here who's going to also kind of watch out and alert me to anything that may come up. And we'll also make sure we have plenty of time to answer questions at the end. So first off, I want to introduce a little bit about Mission, about who we are. Mission is a leading AWS advanced consulting and managed services provider. We're based out of Los Angeles and Boston. We're actually the combination of 3 AWS partners, and we offer a suite of services for architect, migration, management, and optimization in the cloud. Specifically with AWS, we have services kind of across the entire spectrum. So whether you're just getting started with AWS or you have a big business on top, we can help you take full advantage of all of the power of AWS. And if you're interested in learning a little bit more about Mission, there are a couple of handouts attached to the webinar presentation. I would suggest downloading those. There's a great one there called Solutions Architect on Demand. It's a great way to get an hour of free expertise with Mission on AWS to see if we can find ways that we can help your business grow. And if you are interested in being reached out to, we'll have an opportunity at the end for you to indicate as much. So let's dive in today. So what is today's agenda? Well, contextually, there is a growing need for really lightweight services, microservices that can collect huge amounts of data through those web services and then make that data accessible and actionable. AWS and other cloud providers have made a huge focus around management of data and mining insights out of data. And by leveraging some serverless technologies, AWS Lambda specifically, along with the API gateway, it's actually turns out to be really easy now to build scalable management-free web services. So we're going to walk through a quick overview of what it is that I've built, and I'll then go into technical detail about each step in the process. This will get technical, but don't worry, I'm here to answer questions. And if you're not a developer or an engineer, that's okay. You'll get a lot of that anyway out of understanding how all of these things connect together. A lot of the specifics may matter a little bit less to you, and that's great, no problem. So first, let's talk a little bit about what I have built. So I am part of a growing community of people who have gone back to having websites, personal websites, and as sort of a proof of concept around what can be done with Lambda API gateway and some of the services we're going to talk about today. I went ahead and built in location tracking so that I can publish my current location and status about myself in near real time up to my website. In addition to on my website, cleverdevil.io, I have this little status bug at the bottom, which shows my phone battery and Wi-Fi state, whether or not I'm driving or stationary, on a bike. I also have a page which shows my location overlaid on a map, which is really cool. In addition to that, I have captured that location in real time. So as I post new photos or entries, you will see all of that status information, including my location on a map, my elevation, phone charge state, and all of that good stuff. So you may be asking, why would I do this? Well, I also have a private area on my site called the map page. And there I can actually go back in time and see a full map of my movement on a single day on a live interactive map. And I can click on individual data points to dive deeper. And this historical data is only available to me when I'm authenticated. So it's nicely secured. And I really like having this because it helps place a lot of my memories in context. But there's lots of actual practical applications above and beyond my personal site that we'll talk about as well. So here's the solution architecture that I designed, and this is highly applicable to a lot of different use cases. But in essence, the way that this works is I have a mobile device, an iPhone, and that mobile device has an app on it which sends data up to a web service. That web service is actually built on top of the Amazon API gateway, which allows you to expose, kind of custom web services, that are backed by things like AWS Lambda. So behind that, I have several Lambda functions that are actually storing data in what's called a data lake. This is a popular term these days, but in essence, what it is just a large amount of structured data that lives in an object store, or Amazon S3 bucket. And then I'm using a service called Amazon Athena, which allows you to query that data as if it were an SQL database. So that's actually a really amazing thing. When I explain that to people that is something you can do, it kind of blows their mind. So this is one of the many cool things that AWS can provide you. I also have integrations with my website, as you saw, and the end user. And I've done some optimization using scheduled lambdas, which we'll talk about as well. So let's dive in. So again, why would I do this? Well, personal location tracking definitely isn't a common pattern for a lot of people, but these fundamental techniques, as I shared earlier, could be employed in a variety of use cases for business. And in fact, Mission has helped a bunch of businesses with similar architectures, right? So from manufacturing is a good example. If you're trying to do asset tracking or reporting and analytics against your data lake. If you're in ad tech and you want to do location-based targeting, IoT devices, this is a really common use case now. If you have many devices out in the field that are consistently sending information up in real time to the cloud, you can use AWS IoT, or you can go through the API gateway and using a serverless architecture, collect and store a lot of information and then do data aggregation and intelligence on it. So the principles you're learning today are highly applicable to a bunch of other business use cases. So again, a reminder for all of you as you're, we're going through this, feel free to pepper me with questions in the chat. Definitely will keep my eye on that. Just checked out to see if there were any questions yet. Okay, so if we're gonna start somewhere, it should be at step one, which is how to actually build out the web service to collect data. Now, the plan is to implement a whole data ingestion pipeline without requiring any infrastructure to manage. I don't want to create EC2 instances or servers. I don't want to have to use configuration management software. I don't want to have to manage operating system updates. I just want to have code that collects the data I want and stores it in the place that I want it to. So we're going to leverage three basic technologies from AWS here, and then a couple of third-party technologies. So the first we're going to leverage is AWS Lambda. This is what sort of kicked off the serverless kind of terminology. As you may know, of course, with serverless, there are still servers. It's a term that many people do not like, me included, but I tend to think about this more as serverful versus serverless. So it's not less servers necessary, but less management of those servers, right? And AWS Lambda allows you to take a bundle of code and execute it, in a serverless environment, an environment where you don't have to manage the servers. And then in order to expose those functions as web services, we're going to leverage the Amazon API gateway. And that lets us essentially expose those functions as HTTP-based web services. And then finally, we're going to use Amazon S3, which is one of the original AWS cloud services that kind of kicked off AWS's rise. And it is a global object store, and we can transform that into a data lake by using some techniques that we'll discuss later. So that's the plan. And in terms of third-party applications and tools that we're using here, I use a app for iOS that's free called Overland or Overland, and you can find it at overland.p3k.app. You can see that URL in the bottom of the screen there. It's an open source iOS application that's available in the App Store. It's written by a gentleman named Perez, and it actually does the hard work for me here. On device, it collects data about my current location, my battery state, and a bunch of other things. And you can configure it to send data up to an HTTP endpoint in the JSON structured data format. This is a standard kind of structured data format that many services support. And it has a lot of really smart capabilities in the app itself, including buffering. So if you're not online, maybe you're up in the air, for example, and you don't have a network connection, but maybe you are getting GPS signal, it'll store and track and log that locally on device until an internet connection becomes available, and then we'll send up batches, right? So it does all the batching and the buffering, very configurable, great. So this made my life easy, and it had a well-documented API. So that was a big part of why I chose Overland. So next up is looking a little bit at the payload that's sent up. And again, if you're not hyper-technical, don't worry too much about the specifics here, but notice there on the right, it is a payload of structured data, and you can see there's lots of information in there, including geolocation data. It includes timestamps, altitude, speed, accuracy information, a bunch of other data, and it's very well documented, as I mentioned. So each JSON object for each batch is sent via an HTTP post request to a configurable endpoint, and that batch contains an array of locations. So the next technology that I'm using that's kind of separate from AWS is a framework called Zappa. Zappa is available at zappa.io. It's an open source framework that I use because I'm a big Python developer. It's a technology that I generally use to solve problems. I also use Node pretty frequently and a bunch of other technologies, but for me, kind of my language of choice is Python. And AWS Lambda supports Python natively, but a lot of times people find it intimidating to learn something new. And Zappa enables you, if you're already a Python web developer, to use your standard Python web applications and deploy them onto AWS Lambda without really much in the way of changes. So it automatically bundles your application into the native formats. It does the translation using the API gateway, and it even includes remediation for a typical kind of concern for Lambda functions called cold starts. Because Lambda functions are called kind of on demand, sometimes if a function hasn't been called in some time, it will kind of get cycled out. And then when you call that function, it may take a second or two to pull that function back into an availability to be called, right? And in order to remediate that, Zappa has a scheduled kind of task it will do where it sends essentially a no-op, a zero or very, very low cost operation to the function to keep it alive. So that's a very useful thing. It also includes asynchronous task support and integration with things like Certificate Manager and Route 53, so you can map it to your DNS and generate certificates to keep it SSL, keep it secure. So Zappa's great. If you're not using Python, I highly recommend another framework called the Serverless framework, which is available at serverless.com. And it supports a larger variety of languages and runtimes and gives you also kind of portability across multiple cloud platforms. So that's a little bit about the technology. Here is some Python code. Again, don't be too intimidated. The key thing here is at the bottom there are two functions, one called input and one called current. And effectively what I'm doing is data comes in via request HTTP post in JSON format. You'll notice there that I'm storing it I have a storage library here that I'm calling storage, and storage.store with a unique token to identify this device and user, and the payload, the JSON payload. And then I return a status request, status about whether or not that storage succeeded or failed. And then I have the ability to actually fetch information. Now, this is all hidden and available only if you have this unique token. So it's a little bit of, that token can be validated and changed at a later date. Okay, so I'm still watching for questions. You're all a very audience so far. No one's had any major questions, but definitely don't hesitate. So on the storage library that we mentioned before, here you can kind of see I'm using the standard Python Bodo S3 interface. Bodo is the library that open source library that most people use from Python to interface with all of AWS services. And effectively what I'm doing is I'm normalizing the data into a structured format that can then later be mapped in Athena and Glue, which we'll talk about, to make it a data lake. And here you can see that I am also storing data using partitioning. Okay, so what I've done here is I'm partitioning by token and also eventually partitioning by date. And this helps optimize when you're doing queries against your data lake to ensure you're not scanning the entire data set. So this is sort of the beginnings of an S3 data lake. All right. I see I have a question. Looks like it's already been answered by one of my colleagues, so thank you. So now that I've got my standard Python web application here for storing this data, I'm going to use Zappa to then publish that as a Lambda function. So in here, I'm specifying my Python web application, and I am specifying the AWS region that I would like to deploy in. I'm choosing US East 1, and I'm giving it a project name. I'm applying a certificate as well and a domain so that I actually map it to a domain that I have under management with AWS's Route 53 DNS service. And it's using Certificate Manager to actually apply that certificate. And in addition, you'll notice that I have some events, and I'm using a cron-like syntax to say I would like these Lambda functions to be called on a routine basis, right? Daily and halfway through the day. And I also have some additional information there for IAM permissions about what I want this service to be able to reach out and do in my AWS account. So this really gives a lot of extra capability to expose your existing Python web applications or web APIs out as Lambda functions with a lot of native integrations with the rest of AWS. So then you just run Zappa deploy production, and it does all the hard work of generating the CloudFormation templates and provisioning the function, creating the AWS API gateway mappings, and off you go. Okay, so now that I have the data being sent up to my web service, you'll notice here I have just a quick interface showing you what the bucket looks like. And under the current path, I have a current.json partitioned by token that I can fetch and see the latest JSON bundle of data about what my location is. In addition, I have history, which includes all of the historical data, all of the batches ever. And then in order to make it more efficient for querying purposes, I have rollups where I essentially at the end, halfway through each day and at the end of each day, I am querying and generating statically stored historical roll-ups of data. And this is really a useful optimization to make sure that I'm not having to do queries on demand. I'm pre-generating the result sets that I'm interested in so that I can have a more performant and cost-effective solution. Okay, so phase 2 here is to prep for Amazon Athena and using a service called AWS Glue. Now, AWS Glue is a managed ETL service. It helps you map data in your data lake, which is structured maybe in JSON format or CSV, into data tables in the AWS Glue data catalog. Now, what you do is you can use what's called a Glue crawler to actually walk your data and discover and validate the schema, right? And so what we've done here is we've configured, oops, let me go back. We have configured a crawler to look at the bucket specified and including a specific path here for the data that I've collected so far. And the crawler can be run once, or it can be run on a scheduled basis to discover new fields or columns as they come in, and then you can keep your tables up to date. So once I've run the crawler here, you'll notice that the crawler has discovered a schema based on the JSON data that's in the table or in the data lake. And you can see that it's done a pretty good job here of discovering the data types. Now, after you're done, you can go through and you can actually change these data types to guide it in the right direction. But it's a really great way to get started. And it's even discovered partition keys. Now that I have a table defined that is connected to a data source in an S3 bucket, I can actually now query that table using the Amazon Athena service. Now here I'm in the AWS console on the kind of left side there, and you can see I have a standard SQL query. Select XY, altitude, battery state, and battery level from my history table with specific year, month, day kind of bounds. And on the right there, you can see the results that are coming out. And the query is returned very quickly, and if you are partitioning either by token, for example, or by date, it will scan a smaller set of your data lake to reduce your cost, because with Athena, like in most things with Amazon, you pay only for what you use. So you're paying effectively with execution time. So I'm seeing a question here. Somebody has raised their hand. Let me see if I can find those questions. Is this code available for testing purposes? Absolutely. All of this is open source, and I will include links at the very end of the presentation to all of the code so that you can go out and do this yourself and track your own location if you're interested, or you can reapply the same type of solution to your use case. So thanks for the question. Okay. So moving on. Now we've collected a lot of data, and I mentioned earlier, we pay for execution time on Athena. So when I execute that SQL query, however long that execution time is and how much data I'm scanning, I actually pay for that execution time. So it stands to reason that if someone visits my site or I visit my site and want to see data that would generally require a query, I would like to preferably not do those queries repeatedly, right? If I've done it once before, I would like to be able to have those results cached. Now I know that I want a daily view on my map page, which I will visit frequently. And to make that performant, I'm going to do a data rollup with scheduled functions. So as I mentioned, it's inefficient and wasteful, and if you really want to be, as AWS calls it, well-architected and cost-optimized, you want to be sure to, leverage a technique like this. So what I've done is I've created some simple Lambda functions that are scheduled via Zappa. You can also schedule Lambda functions in the AWS console, or you can use CloudFormation templates to, kind of use more of infrastructure as code type best practices to schedule your functions. And then you basically edit your zappa.json file, which I've mentioned earlier, and you can put in cron syntax and say this function will be called, please, on this kind of regular cadence. So I've also added a web service endpoint to fetch static daily rollups from S3 and publish that up as well. Okay, so here you can see, earlier you saw I was doing an on-demand query through the AWS console. Well, here I'm going to do the exact same query or a very similar query using the Bodo library. So you can see there on the left-hand side, I'm templatizing the query and then outputting the results into a specific location so that my web service will know where to pull them from. And what I'm doing is I'm then passing that through the Boto library, and it's actually executing the request, and Athena stores its output as a CSV file in a specific output location. So I got another question that came up. Is it possible to get the recording of this webinar for people that joined in late to make reference to? Absolutely. If you are here or you're registered, we will make sure to send an email to you after the webinar with a link once we upload it. I believe we'll have it on YouTube, so you can watch it. It's a good question. Okay. So next up, we're going to actually make use of this data lake and all of our web services and integrate it with my website. Now, in order to do that, I am using a JavaScript-based mapping library called MapKit.js from Apple, believe it or not. Google Maps is a great service as well. There are also open source, mapping libraries based upon the OpenStreetMap service. So really, this is just an example, right, to give you an idea. I use a PHP-based CMS on my site. So all I'm really doing here is fetching data from my web service endpoint that I've defined and reading out the JSON, kind of payloads that come back, and then I'm injecting that data into a map so that I can actually render it on my site. So let's now talk through kind of wrapping up our whole architecture and kind of what we've built and how we built it, and we'll have a lot more time for questions as well. So again, reviewing the solution architecture, my mobile device is using that Overland app to do the actual data collection. It is routinely on a scheduled basis posting batches of data up to a web service. That web service is a standard Python web application using a standard Python web framework. And it is using the Zappa project and framework to then translate that up into a Lambda function that you can call as a web service using the API gateway. That is storing data into an S3 bucket, which is then crawled with AWS Glue to transform it and ETL it into a data lake, which I then query with Athena, which allows me to do standard SQL calls against that data lake. And I'm doing scheduled Lambda function rollups to optimize my performance and my cost. And then my website integrates with that standard web service, just I would integrate with any other web service to provide my end users with what they're looking for. Now, as I mentioned before, we work with a lot of different types of companies, and IoT is a very common use case for this type of workload. And you can swap out that API gateway for AWS's IoT service, which will then do things like device management, and it speaks additional protocols like MQTT. And you map those calls directly to Lambda functions as well. And the beauty of it is the architecture will work just as well there. Now, why would I use an architecture like this? Well, the nice thing is, because it's completely serverless, there's no management for me to do. I don't have to go in and keep the operating system up to date or make sure the web service is running or any of that. I just deploy my code. I only pay for my usage. And because in this particular use case, I'm sending up, hundreds of thousands of data points a day, but I'm doing it in 5-minute batches. So my cost for running this service is I think it's around 8 cents a month, all in, right? And that includes the querying and the storage. And I've been running this for quite some time now. So I have a pretty healthy size database of my location history. And the other nice thing about a serverless architecture is it makes scaling a little bit more seamless, right? So if you did have an IoT-based workload, and as you add more and more devices out to the field, Lambda functions kind of can be run massively in parallel. And so you kind of take the burden of that away from yourself. So I got a great question here, actually a mention from Scott Fast saying, hey, just to mention that this truly appears to be a well-architected solution. Nice work and great optimization ideas. Thank you very much. That's sort of what we endeavor to do, is to help people design well-architected solutions and help people become well-architected. So for those of you who aren't familiar, well-architected is a framework that AWS has defined to help make sure that you're cost optimized, performance, scalable, efficient, all of those things. And we actually have just completed earlier this, or I guess late last year, a 5-part series on well architected that I did. So you can go back and view those as well if you want to learn more about it. So that's the solution architecture and review. So some conclusions. We went over quite a bit of ground today. So we talked about serverless kind of in general as a concept, and I wanted to be sure that I helped you know that even if your developers have never used Lambda before, there are great ways for you to, frameworks out there like the serverless framework and Zappa that allow you to take an existing application and workload and start that transition. So that's a big key thing that I would drive home. In addition, the API gateway itself takes away a lot of the burden for you on designing and managing your API and scaling it as well, sort of the front end for it. And I guess the second layer of really interesting kind of stuff we talked about today was really around data and analytics, right? Using Amazon S3 as a data lake and then exposing out insights with AWS Glue and Amazon Athena. I'll also mention that you can even connect Amazon's Redshift using Redshift Spectrum to an S3 data lake and do full-scale data warehousing against an S3 bucket. So it really is sort of a largely overlooked part of Amazon S3. People think of it as just a place to store information. And as it turns out, as data becomes more and more useful to businesses and manufacturing companies, advertising companies, there's so many use cases to go out and really understand that data. And AWS with Glue and Athena and S3 is really giving you a powerful suite of services to do that at very low cost, only to pay for what you use. So as I mentioned before, all the source code is available for the project. There are the links right there. And again, I'm very happy to answer any questions that people have. So I'm going to start going through some of those questions. Are there any services that have PHP? So I'm going to assume the question there is, can you write Lambda functions with PHP? And the answer to that question is, yes, you can now. AWS does not have a native runtime for PHP presently, but at the most recent AWS reInvent, Amazon announced a new evolution of AWS Lambda called Layers. And Layers allows you to bundle custom packages and code up into reusable bundles for functions. And it allows you to create effectively custom runtimes. So there are people out there now, partners that have developed PHP-backed capabilities for building out Lambda functions. So in terms of full take this existing PHP web service and deploy it. I'm not aware of any right now, but I know there are some great ones out there in development. So I think it's sort of an emerging category. But my advice to most people would be to check out the serverless framework that I mentioned earlier. Okay, so the next question is from Ken. Ken had a question about the data collector. Let's say your data collector is upgraded and additional fields are added to the data captured in S3. Will Athena continue to retrieve the new data, ignoring the extra fields, or must I recreate my Athena source? That's a great question. The way that AWS Glue crawlers work is when you run them on a scheduled basis, you have the capability to configure, and I'm going to turn off my video momentarily to make sure that we don't have any audio problems. We're having a little bit of a dropout at the moment. So to answer the question, AWS Glue crawlers can be configured such that if new fields are discovered, you have the option to either update the existing table in place, to create a new one, to notify, to merge, all sorts of different options. So the answer to your question is, it depends on what you want, right? In my world, I actually have run the crawler. I've stopped running the crawler because I know my data set isn't changing in terms of its schema. And it really does simplify things. I think one of the big challenges with Glue crawlers is that they're expensive to run. And the reason they're expensive to run is because they have to scan all of the data in your data lake, right? And that is an expensive operation if you have a very large data lake. So that's a thing to keep in mind in terms of being optimized. Okay, the next question. from Ankit, who said that handshaking required for getting data from devices on a regular basis, or is handshaking required for getting data from a device on a regular basis? So the device is not keeping a persistent streaming data connection open. What it's actually doing is on a configurable interval, it's setting up a batch. And I'm using HTTP for this example, but I have worked with a couple customers at Mission before who prefer other protocols, right? Maybe a custom protocol or something like an MQTT. So it really does come down to the use case, right? For me, because I'm sending batches on a 5-minute interval, the overhead of HTTP is completely acceptable to me, and I'm not looking for real time, just near real time. But if you have more real time requirements, something like MQTT or something custom might be a better fit for you. So the next question was from Scott Fast, and his question is about why don't I use Glacier versus an S3 bucket? And that is an awesome question. In terms of being cost optimized, my next phase of this project would be to put in lifecycle rules to transition data out from my S3 bucket into a Glacier store, and that would reduce my cost. Now, the answer as to why I haven't done it is because I'm storing very small amounts in terms of not in terms of volume, but in terms of data size of JSON, right? It's plain text, it's very, very small, and while there are, at this point, millions of objects, the amount of savings I would get out of the storage, again, is very small. So I'm paying 8 cents a month right now, not high priority for me, but if you have a petabyte scale data lake, obviously you would get huge amount of benefit, and you can use a Glacier bucket with many of the data analytics services from AWS. So the next question came from Gerson, who says, is it possible to have an issue with ISO compliance about personal information? So above and beyond ISO, there are lots and lots of different requirements. GDPR, for example, around compliance. And compliance with Amazon is definitely something that we provide help with and assistance with. We frequently recommend people use tools to do best practice checks and compliance checks on a regular basis. All of the data that I'm storing in my data lake is in a private bucket that only I have access to and my systems have access to using IAM, and that is a big part of it. We have also helped other customers in the past to tag objects in S3 with information, tying it back to records for doing things like data purges or data fetches, so to comply with GDPR. So you can attach an identifying information, even in a sort of like too blind way, such that you can't actually track it back to an individual so that someone could request their data as a download. So S3 gives you a lot of capabilities for that purpose. Okay, another question was Patrick Steger. Why did your architecture show 2 lambdas between the API gateway and S3? Just because there are different functions being used. So the answer is that, so technically speaking, the way I'm using Zappa is it is a single Lambda function that all requests are routed into. So you're right, it's actually not multiple Lambdas. Now, this is an important thing to note. If you are using a technique like this is a weakness of this technique. One of the beauties of using Lambda is that you can break your applications down into very discrete units of code, functions that do one thing really, really well. And by using kind of cloud management platforms like we provide at Mission, we can go down and drill in and say, this specific function is for, generating 30% of your compute costs this month. And so on an application by application basis, we can provide really deep insights into where you need to optimize. This is sort of a game changer for developers. If you are a developer or have an engineering team who is constantly hounding you about refactoring, this is the best MO you will ever get for justifying an ROI on re-architecting or refactoring pieces of your application. Because you can say, this function, which is providing this feature, is providing us exactly this cost. If I reduce the execution time of that function, optimize it by 20%, this is the exact dollars and cents that we would save. So I think it's an aspect of serverless that's often overlooked, and it's definitely a weak part of using a framework like Zappa to translate back down. Now, you can still get those kind of capabilities by breaking down into multiple smaller web services, but it is a factor to consider when architecting. Thank you, Patrick. That was a great question. So another question is, can we use PHP APIs or patch files to run Lambda? So as I mentioned earlier, there are people out there who have worked on layers for doing PHP-based Lambdas and really toolkits and frameworks that are coming up. So I would say it's an emerging category, and it's not one that I personally have dived deep into, but definitely there are things out there on GitHub. So Scott mentioned lifecycle management is smart on the data storage question, and yes, it really is. You can, we help customers that all the time, making sure there's lots of different kind of levels of storage to consider with AWS, and they keep adding more. And mapping your use cases to the right storage is definitely a big thing we help customers with to help them save money. Another question from Scott. Do I get any interest from law enforcement or the FBI or trucking and logistic companies or ride-sharing businesses like Uber, Lyft for this kind of app? That's a great question. So as you will know, many of those organizations and businesses are in fact customers of AWS. And if you look at AWS's website for Lambda and for specifically things like data lakes, you will see a whole huge set of great case studies there. Also on our website, we've got a lot of use cases and case studies for customers that we've helped implement things like this. All right, great engaging questions so far, everybody. I really appreciate it. I think we're getting into the end of questions. So while we wait for a couple more questions to come in. Earlier, I did mention the Solutions Architect on Demand program. So if you want to connect after this webinar for an hour with one of our experts, go through some of the challenges that your business is facing and find ways that we can help you, no risk kind of thing, definitely download the handout, and also go ahead into the chat and just type the word yes. If you type the word yes and enter that into the chat, we'll register you as someone who's interested and make sure to reach out to you. And as a follow-up, as I mentioned to this webinar, we'll be sure to share out any links, information that you might be interested in to case studies and white papers and so on, and a link to eventually the recording of this webinar so you can share with all of your friends and colleagues. So I'm going to wait for any more questions that might come up, but it's looking like we don't have any new questions at the moment. I'll give one more minute. But again, thank you so much for joining. I'm seeing some yeses flow in. Definitely love to help businesses meet their challenges with AWS. And if you would like to reach out, you can always reach out and find me. I'm Clever Devil on Twitter, cleverdevil.io on my website, which includes a lot of other links out to my GitHub profile and other places where you can find some of the code and information about today's webinar. So thank you so much, and look forward to speaking with all of you again on more serverless topics over the next couple months. Thank you. And actually, while some people are still on, we do have some more questions coming in. So I'm going to go ahead and answer those because we still have some time. I want to make sure to get to them. There was a question about, can you use a Lambda as a cron job? And the answer is, you can schedule Lambda function executions using cron syntax, or using a different syntax in kind of the same way you would use a cron job. This is one of the most common use cases for me, is if you go into a legacy application, look at ways that you're using scheduled cron jobs, and then repurpose those as Lambda functions that are scheduled. Getting some good thank yous from people. Thank you so much. Okay, I think we have answered all the questions now. Thank you again. Thank you all for attending, and we'll see you next time.